In this video, I am doing a repeated measure ANOVA test, and it's the third problem of the three that we were given that I'm working on. To begin, I did the degrees of freedom and find the critical region that we're working in. This is the equation for the degrees of freedom within minus degrees of freedom between treatments. 12 minus 3, I get, so 12 minus 3 and then 4 minus 1. I get 6. So this is, my numerator and denominator. Look it up. I get 4.76 is my critical region. And over here I did the between subjects degrees of freedom. So this is all the information. We have 4 subjects. There's 3 different types of treatments. This is the reported amount of objects. We're dealing with kleptomanias. And this is the amount of objects they stole. So number 1 stole 6 in the first treatment, 2 in the second, and 3 in the third. And then I have those totals over here for those individual subjects. And then I have the total for those individual treatments here, the complete total of those right here, G. And I also did the sum of squares. For the first treatment, well, for all of them, I had to square these X values individually and add them up for each treatment. So, 6 squared, 36, plus 25, that's 5 squared, 0, 0 squared, 1, 1. And you get 62 minus this total squared divided by how many are in the treatment, 4. And I just solved through. I did that for each treatment. I did that, the squaring on the side, just so it wouldn't be as messy. But, 2 squares 4 plus 1 plus 25 plus 64, that's 94 altogether. And for this right here, it's going to be 9, 36, 104. Add those all up. And then I do have the totals for those right here without being squared. So with all those, I solved through. Treatment 1, sum of squares 26. And the sum of squares for treatment 2 is 30. And the sum of squares for treatment 3 is 38.75. And I added up all of those over here to use on later for some more calculating. Yay! For sum of squares between treatments, you're using this total value you got for each of the treatments, squaring it and dividing it by how many were in each of those treatments, so 4 are in each group. Add those up and then minus it by the total number of all, I guess, what you ended up getting, your results, divided by how many were participating in each treatment. So there's 12 overall. So I solve that through, square it first, so that'd be 144 divided by 4, etc., etc., etc. And here's my calculations for that, minus, this ended up being 200.083. And you get your sum of squares between treatments as 10.167. I also did the sum of squares between subjects, because we also need that as well. And we use these numbers that we added up on the side. So these are the individual subjects' total amount of objects they had stolen individually. So you square those just like you did over here. And then you divide it by 3, because there's 3 different types of treatments. Because that's how many treatments they were in. So you square it, divide it by 3. Do that for each individual one of these. Use the same amount of these total sum and divide it by the same how many there were in each group. And you get 3.58. Here's the other calculations from this. But you get 3.58 as your sum of squares between subjects. Now we must calculate the sum of squares error. And that we use the sum of squares within treatment minus the sum of squares between subjects. So just plug in those numbers. So this was my total sum of squares within 94.75 minus 3.58, which we just found, and you get 91.17. Now we're going on to our mean. I just temporarily forgot what this stands for, but whatever. MS between treatment. So I do sum of squares between treatment divided by degrees of freedom between treatment. Solve that out, you get 3.389, and then I need to find the MS error, so I do sum of squares error divided by degrees of freedom error, and I get this as well. And we're going to need both of these to find our F value. So plug that in, have the formula here, plug it in, solve through, and I get 0.22. I started doing an effect size, but I remember you don't have to do an effect size if you have to fail to reject, which in our case we do, because our critical region's right here, and this is where our F value is. I also made a table and plugged in all the numbers here of all of our sum of squares, our degrees of freedom, and now forgetting this word, and these are our totals, so keep in check what I've been doing. And then our F value. So we fail to reject the null. There is no significant difference among the treatments and the amount of objects stolen by the participants. And then this is our proof of why. Alright, and that is my video of repeated squares. Bye!